All right, let's get started. Thanks for joining this Telit webinar, How Wi-Fi 6 Transforms Digital Business to Create Smarter Verticals. I'm Amanda Slink, the Head of Global Events here at Telit, and I'll be moderating today's event. To explain this topic today, I'm pleased to be joined by Carmelo D'Agostino, Product Manager at Telit. Hi, Carmelo.
Hello, everybody. Hello, Amanda.
Just before I hand it over to Carmelo to start our presentation, I have a few quick housekeeping items. I would like to remind our audience that we will have time to answer some questions at the end of our presentation. You can simply submit a question by posting in the questions box located near the bottom of your screen. Also, be sure to check out the resources section for some additional information on our topic. And finally, we will send out the replay link to all attendees at the conclusion of the webinar, so be on the lookout for that. And with that, Carmelo, I will hand it over to you to start our presentation.
Thank you, Amanda. And again, welcome everybody to this webinar. I'm Carmelo. I'm product manager in Telit. I've been in the company for a couple of years. And today, as Amanda mentioned, we are going to talk about Wi-Fi 6 and how this new standard can help to transform digital business in order to make smarter vertical, helping connecting machine, materials, people, process, products and services, everything, finally creating a greater value for the end customer. So just before talking in details about Wi-Fi 6, let me shortly introduce Telit. So Telit enables IoT solution with modules, connectivity plans, platform, and software as services. Telit has a large portfolio of hardware modules ranging from short-range modules. We are going to see them later. When I talk about short-range, I mean Bluetooth and Wi-Fi. We have a cellular module, 2G, 3G, LTE, and 5G, and positioning modules. On top of all this, Telit offers cellular data plans and full connectivity solution, making your IoT solution easy to implement and maintain. Now, let's talk about Wi-Fi. Today, Wi-Fi is for sure a household name that is synonymous with delivering high-capacity wireless services that are used to support the vast majority of smartphone data usage. This cost-effective technology, coupled with an open ecosystem with easy way to upgrade, and so that every already deployed devices can be in any way used. Since technology is backward compatible. So this technology, as saying, has created an astounding successful market, which in the last years only saw the deployment of over 4 billion new Wi-Fi devices. Of course, this growth is coming from multiple different product categories with different key requirements. We can think about IoT use cases that require low data rates and low power consumption, and so they are based on small battery-powered devices. But at the same time, we can think also other systems like augmented reality or virtual reality user case that will require extremely high throughput and low latency solution. Wi-Fi is not a recent technology. Wi-Fi has existed since the late 90s, and indeed 3 years now ago, in 2019, the Wi-Fi Alliance has marked its 20th anniversary. And the technology has improved dramatically, particularly in the last decades. Wi-Fi 6, as you can see here in this small table, Wi-Fi 6 technology has a substantial upgrade of previous generation. And we are going to see in details what are the main difference compared to past generation. For sure, speed is the most notable characteristic, with the 9.6 gigabit per second of maximum output power of Wi-Fi 6 across multiple channels. For sure, this looks a big improvement compared to the 3.25 gigabit per second offered by Wi-Fi 6, but we should not forget that this capacity is shared across all the connected devices, and as we are going to see, Wi-Fi 6 can support more devices than Wi-Fi 5. Talking again about Wi-Fi 6, also this technology also offers improved latency, bundling network traffic more efficiently. And in the next slide, we are going to see more details about this. Wi-Fi 6 has adopted orthogonal frequency division multiplexing access, or in short is OFMDA, which provides support for high-density deployments, enabling more efficient allocation of bandwidth to multiple users simultaneously. This will also help reduce power consumption on devices, ensuring that the end user will receive high-quality connectivity without regularly searching for the bandwidth. So let's talk a little bit more in details about Wi-Fi 6 from the technology point of view. Let's say that this latest standard addresses today's biggest Wi-Fi challenge: performance and increased density of devices and diversity of applications. The standard implements several new features that altogether help to achieve this objective. First of all, let's talk about BSS coloring, or Basic Service Set Coloring. This allows to assign a color, let's call it color, to data from each Wi-Fi access point, so that the network can differentiate between Wi-Fi network operating in overlapping frequencies. In other words, let me explain better. BSS coloring allows network to identify who is transmitting, so that collision can be mitigating, collision that comes from nearby network. And this will result in overall better network performance. A practical example, this will be useful in venues, big venues such retail malls, multi-welding units, etc. The next Wi-Fi 6 feature and technology that is implemented in this standard that I would like to mention is the orthogonal frequency division multiple access, or as I mentioned before, the OFDMA. What this means? OFDMA is the multi-user version of the orthogonal frequency division multiplexing modulation that was used by the previous version of the Wi-Fi standard. The Wi-Fi 6 uses OFDMA for increased efficiency. Basically, to explain, we can imagine our Wi-Fi connection as a series of delivery tracks delivering data packet to our devices. With the previous version of the standard, each delivery track or packet could only deliver one parcel to one device at a time. Now, with Wi-Fi 6 and with the implementation of the OFDMA, each track can deliver multiple parcels to multiple devices simultaneously. This vast improvement in efficiency works for both uploads and downloads. Okay, so this is a very critical point. In other words, we can say that the OFDMA improves Wi-Fi performance, particularly in high-density, high-throughput environments, such as a stadium or a big auditorium. We can talk now about the 1024 QAM that is implemented by Wi-Fi 6. Basically, this is a faster modulation scheme that helps to pack more data. With 1024 QAM, each symbol indeed carries 10 bits rather than 8 bits that was packed in the previous generation of Wi-Fi. Practically, this modulation helps to increase throughput in Wi-Fi network by encoding more data in the same amount of spectrum. So if we consider now that we have 10 bits, earlier we had 8 bits, we are basically improving the raw speed by 25% compared to older modulation schemes. And this will be really helpful to support new user cases, such as ultra video streaming, advanced augmented reality, virtual reality, and next generation of e-classroom, let's say, if we have to continue learning remotely. Now, if we think about user case in the other range of the spectrum, so in the IoT low power space, I think that Wi-Fi 6 also offers the right solution. Indeed, with the introduction of the target wake time, or for short TWT, battery life is improved by increasing the time that the device spends sleeping. So the battery life is the battery will last longer. This feature is available for all Wi-Fi 6 devices, but as I was mentioning, it will be for sure useful for IoT solution and devices. Another interesting feature is the multiple user MIMO. This stands for multi-user, multiple input, multiple output. Wi-Fi 6 basically is capable of simultaneously maintaining 8 streams of data. We normally say 8 by 8, and 8 by 8 multi-user MIMO potentially double the data rate compared to the previous generation of the 4 by 4 multiple user MIMO. Indeed, we can think if we see nowadays Wi-Fi network, let's say traditional already implemented multiple user MIMO, in this situation already multiple user could access the router at the same time, and normally we don't see any decrease in bandwidth quality, but with the new application this is going to change. This is why the 8 by 8 multiple user MIMO with this technology, more than 8 streams are available for user to choose. And whereas in the older technologies, in the older version of the standard, so in Wi-Fi 6, the multiple user MIMO worked for downloads, with Wi-Fi 6, the multiple user MIMO works with uploads and downloads. Again, this is a significant capacity boost and addresses use cases from enterprise network, large public venues, and multiple dwelling buildings. The last but not least point that I would like to mention in this short Wi-Fi 6 introduction is security. As we know, security is becoming more and more critical for our network infrastructure. This is the reason why all Wi-Fi 6 devices support WPA3 personal encryption, and to add an extra layer of security, also WPA3 enterprise can be supported. Okay. Now, after this short overview of the technical feature let's say, there are several more that I've not illustrated, but there are several more new features that Wi-Fi 6 offers. So after this short introduction, I would like to move to some real and innovative user case that can be enabled by this new standard. I will start with user case in smart cities, in a smart home. We'll talk a little bit about healthcare, smart car, smart factory, and we'll finish with retail user cases that can be enabled or improved by the use of Wi-Fi 6. So let's start with smart cities. As we have seen, Wi-Fi 6 enable significantly faster throughput in high-density environments, where we have many devices that use the same wireless access point. And this feature can be really beneficial for smart city use cases. Indeed, if we think about the standard, the increased network performance in high-density network is one of the primary goals of Wi-Fi 6. Service providers deploying Wi-Fi 6 in high-density area, for example, a stadium, airport, train station, shopping malls, and college, can benefit from the multi-user scheduling and BSS coloring. So this will enable more devices to be supported while delivering a better overall user experience. Smart vehicle can use Wi-Fi 6 at the same time cellular connection, 5G, to ramp up the communication with the public transport infrastructure. And at the same time, they will be able to communicate more effectively with other vehicles while moving around the city. If we think about real-time traffic monitoring, if they are equipped with Wi-Fi 6 technology, this system could use artificial intelligence algorithms to perform advanced video analytics in response to current condition, so that they can control signal or lights or open line in order to optimize the traffic through the city and hence minimize delay. If we think behind the highway, so what is the side, the real-time responsiveness and ability to connect many more devices will let Wi-Fi 6 enhance also pedestrian area and bike path. For example, we can think of lampposts that could turn on and off as needed when there are people around them, for example. Or we can think about sensor that could send real-time alert to warn everyone of oncoming traffic, or if there are pedestrians that are crossing the street. Geofencing, that basically is used to monitor activity within a preset geographical boundary, can be used to manage more precisely water and energy according to real-time events like sudden changed weather or a public gathering or similar occasion. Within the city infrastructure, again, the high-density capability integrated into the 11AX, as it's called, it's the real name of the Wi-Fi 6, helped with 5G cellular technology, could enhance essential services, such as the performance of the utility grid and the waste management. To conclude this chapter about user case and smart cities, I would say that Wi-Fi 6 can bring many benefits, but for big projects like the smart cities, this change should be undertaken very paying a lot of attention. Because if we think a full Wi-Fi 6 deployment, this will mean changing access point, client, and also the full infrastructure. So this is a big step, and it's very hard to be taken in one leap. So what it's suggested, and what normally is a good strategy, would be to look for a gradual upgrade path, making so basically sure that anything that is now added to the network is already ready, and Wi-Fi 6 is everything that is added will be able to support the new standard and the Wi-Fi 6. Let's now change environment and move inside our homes. As we know, our homes are becoming more and more smart, and they are integrating an increasing number of devices requiring wireless connection. Uh, as we have seen, Wi-Fi 6 support a very big, diverse set of device and application, and the standard provides lower latency and lower power consumption for IoT scenario that will be useful today and also for tomorrow smart homes. So, for example, imagine after a long day at work, you come back home and you don't want any stress. You want to simply the best internet connection anywhere, anytime. Now, till now, interference from your neighbor wireless network could cause issues with your wireless signals. Wi-Fi 6 is here to help. As I mentioned before, Wi-Fi 6 supports the BSS, so the base service station color. That, as I mentioned before, it marks frames from the different neighborhood routers, so that your router could ignore them. In other words, if you ever lived in an apartment that is very close to your neighbor, as it happens normally nowadays cities, this means that if you just upgrade your modem, your router to Wi-Fi 6, the network will become instantly more efficient. Furthermore, I mentioned this before, more high bandwidth entertainment are coming to our homes. I'm thinking about augmented reality, virtual reality gaming, 4K streaming, and even 8K streaming. These are applications. The use of Wi-Fi 6 devices will help to receive better individual experience. As I mentioned before, Wi-Fi 6 supports 8x8 multiple user MIMO that works with upload and downloads at the same time. This was not true for previous Wi-Fi for the previous Wi-Fi standard. Practically, this means that whenever you are streaming a film, playing a video game in virtual reality, in augmented reality, the multiple user multiple user MIMOs provided by the Wi-Fi 6 will give enough bandwidth for everyone in the house to enjoy their activity without issues. Indeed, there is something that I've not mentioned in my previous Wi-Fi technical slide. Basically, Wi-Fi 6 also expand the Wi-Fi band from the 8 MHz to the 160 MHz, doubling the channel width and basically creating a faster connection from your router to the device. This means that using Wi-Fi 6 devices, you can enjoy 8K movies, a responsive smart IoT system, appliance, accessory, outdoor IP-enabled security camera, all together without any buffering. So there is enough band for everything. Just a final note on the smart home. There are a recent survey that also found new pattern of connecting to the internet from home. And this interview, people in this interview, the 65% of the people interviewed in this study admitted that they are now Hello? Can you hear me?
Yep, we can hear you.
Okay, sorry, I don't know why half an hour the call dropped. The Teams
Okay.
call dropped. Exactly at the half hour mark dropped. Okay, I will start from the last paragraph that I was mentioning, and maybe you can join it later in back production.
Yep, not a
Is
problem.
it fine? Okay, I start again. So finally, something that I want to mention to conclude this chapter about smart homes. I found recent surveys that where people these studies that showed a new pattern of connecting to the internet at home, and the 65% of the interviewed people admitted using Wi-Fi in usual places in their homes, such as garages, attics, or patio. This, I think, for sure correlate with the sudden and unexpected rise in remote working and learning due to the COVID-19 pandemic. But the point is that half of the people in these surveys that they had area in their home where Wi-Fi didn't work as expected, and this demonstrates a significant need for the full home Wi-Fi solution. Now, Wi-Fi 6 with longer OFM symbols could be the solution, providing increased coverage and making it at the same time faster. Let's move to another vertical, so healthcare. According to the FMI, the global IT in healthcare market is projected to reach 181 billion US dollar in 2022, and even more, it is anticipated to grow to a CAGR of 18%, reaching a staggering 952 billion US dollar by 2032. So big numbers. I would like to take an example of Wi-Fi 6 application in a real example, so a modern hospital. So as you know, Wi-Fi is quite common in hospital given the many benefit it provides. So we can think of devices that are connected and communicating for accurate patient's record and real-time data analysis. Nurses can monitor many patients remotely from one main station, and they receive alerts and observe data captured each second. Doctor can make informed decision with accurate and up-to-date patient information, leading to better patient outcomes. And finally, on their side, patients can feel safer, knowing that they will always receive the right and correct dosage of their medication. So, in short, I could describe a hospital like dynamic buildings with multiple wireless devices per person, variability with people and devices constantly on the move, and noise from all the other technologies that are present in the hospital. But we are seeing even growing number of wireless devices, and with this comes a lot of noise and potential issues. Luckily, Wi-Fi 6 is here to help us. So I would say that modern hospitals are the perfect example of a congested, high traffic, constantly changing environment that would really benefit from the Wi-Fi 6 capability to address all those devices in one space. Let me make a concrete example. So let's take a Wi-Fi enabled infusion pump that could take advantage of the Wi-Fi 6 feature. In particular, of the Wi-Fi 6 scheduling based resource allocation. This means that this infusion pump, alongside with the other devices and the access point, could negotiate and define a specific time to send the data, reducing the contention and overlap with all the other devices. Furthermore, with the OFDMA that is implemented by Wi-Fi 6, up to other 30 devices could share the same channel with our infusion pump. And this means that they are not going to take turns. As a result, the infusion pump will see reduced power consumption because basically it can stay in a sleep mode for longer time, and from a technical point of view, the transmission can even drop fewer packets. In conclusion, I can say that Wi-Fi 6 medical devices will work better together, stay connected better, and be more reliable for an overall better experience. Another case where the high bandwidth provided by Wi-Fi 6 could be beneficial is for remote medical consultation. I mean, remote medical consultation were not really common some years ago, but now people are starting to accept them more and more overall after the COVID-19 pandemic. Finally, the low latency provided by the Wi-Fi 6 standard can enable more and more futuristic application in healthcare. I'm thinking about, for example, a medical procedure using a remote controlled robot, meaning a doctor staying in some place of the world and the robot operating in other side of the world. Everything working seamless. Let's change again environment and let's talk about Wi-Fi 6 in the industry. I could list several scenarios where modern industry, or we call it Industry 4.0, could benefit from Wi-Fi 6 technical advancement. But I would like to focus on three, let's say, simplified examples. First, we can think about industrial control system. These devices requires more and more high throughput and low latency wireless communication in order to work in a better way. A second example could be battery-operated devices such as sensor. These devices generally require low power consumption and low bandwidth. And as I mentioned before, this can be easily achieved by the TWT, so target wait time feature that is offered by Wi-Fi 6. Finally, as we have seen, Wi-Fi 6 also offers lower latency and increased determinism. This will definitely improve control and management of automated guided vehicles, or AVG as we call it, within industrial environments. What's more, as the number and density of IoT devices increase dramatically in the industry, we need technology such as the Wi-Fi 6 to support the higher number of simultaneous connection, while at the same time avoiding interference due to cross coverage. By using OFDMA, multiple user MIMO, TWT, BSS coloring, and special reuse technologies, while Wi-Fi 6 could offer excellent performance and resistance to interference even when the density of this device becomes very high. To conclude this short case analysis, let's talk a little bit about the advantages that Wi-Fi 6 can bring in the retail vertical. We have seen in the last years the growing cost of storage has forced the retailers to find ways to improve control over the inventory and storage. Indeed, there are already several technologies that can help with this. Indoor Global Positioning System and Radio Frequency Identification Tags, RFID, offer means to locate parts and provide inventory remotely. However, Wi-Fi-enabled mobile devices are really useful in checking deliveries and monitoring shipping, for example. The new Wi-Fi 6 frame structure is to give you some background. The new Wi-Fi 6 frame structure is targeted as being used as the foundation for delivering improved accuracy for Wi-Fi based location determination. These can definitely help advanced automated pick-and-place robot and conveyors that are used to prepare deliveries for customers, for example. I'm thinking to some modern storage implemented by well-known online retail store, as example. Finally, the lower cost of all the supply chain management can sure benefit the final customer for the price, or at the same time increase the margin for the seller. Looking forward, indeed, also brick and mortar shops could benefit could exploit Wi-Fi 6 location technology or high definition video streaming coupled with some sort of machine learning or artificial intelligence analysis to optimize targeted advertisement systems. And finally, as I mentioned before, geofencing can deliver a personalized message to people as they pass by, announcing upcoming events or nearby discount for retailers and for food outlets. So this concludes the first part of this webinar, or the use case analysis. And now I would like to talk a little bit about Telit module portfolio. As I was mentioned at the beginning of this webinar, Telit commercializes solutions supporting cellular IoT, like low power wide area network, LTE, 2G, cellular broadband modules such as LTE and 5G, positioning modules, GPS, and short range modules. In particular, when talking about short range, we can see that, as shown in this slide, the offering is quite large. Telit have modules supporting Bluetooth and Wi-Fi standard. They are all combo, as we say, combo modules. We have our W310F5, that is Wi-Fi 4 single band modules, and the W310G4 that is always Wi-Fi 4, but this time is dual band, so 2.4 and 5 gigahertz modules. We have the WE866C6 that is Wi-Fi 5 dual band modules, and this is a very excellent companion module for our LTE cellular modules. And finally, I'm proud to announce that we are working on a new upcoming module that will support the latest Wi-Fi 6 standard. All our modules are based on surface mount technology that will help to enhance their robustness, and the LJ package ensure that they can be easily embedded into sales constrained application. This, coupled with the fact that they support an extended operating temperature range, enable our modules to be to meet Wi-Fi Bluetooth design requirement for industrial space. And with this, I conclude my presentation, Amanda, and I wait for a question from our public. Thank you.
Yep, thanks, Carmelo. Right before we get to the questions, I am going to drop a poll on the screen for our audience here. If you'd like to have one of our our experts contact you directly, please just respond here on the poll, and we'll get someone to reach out to you. We do have time for a few questions now. There is still time to ask a question, so please submit using the box on your screen, and we'll do our best to cover it. Carmelo, we've gotten quite a few already, so we'll just kind of dive right in here. First question, okay. Can you explain the difference between Wi-Fi 6 and Wi-Fi 6E?
Yes, indeed. Thank you for this. This is an excellent question. Indeed, I didn't talk about Wi-Fi 6E in my slides, since technically Wi-Fi 6E is quite similar to Wi-Fi 6. The only difference is the E that stands for extended. Extended means that Wi-Fi 6E define the use of the 6 gigahertz band. So to say it simple, Wi-Fi 6E means Wi-Fi 6 extended to the 6 gigahertz band. So 6 gigahertz is the new frequency band that allows additional spectrum, giving if you have a Wi-Fi 6 E device, you have access to the 6 gigahertz frequency. That brings more bandwidth, faster speed, and even lower latency. So this can open up resources for new innovation. Again, I mentioned before augmented reality, virtual reality, but we can think about 8K streaming and more. Okay, I hope this answer briefly the question.
Great, thank you. Next one we've got here. What do you think of the integration of Wi-Fi 6 and 5G cellular networks? It's an interesting question.
Oh, yes. Really important point to discuss. So I think that both technologies, so Wi-Fi 6 and 5G, will have an important role to play in the future of wireless. And this is different compared to past generation of wireless. In this case, it's not an either or decision. I would say that 5G and Wi-Fi network will need and will be able to interoperate with each other, and they are going to be seen as complementary in the complete ecosystem. So during this presentation, we have seen several use cases where Wi-Fi 6 can bring important benefits. However, sometimes just Wi-Fi 6 is not enough for all kind of application. For example, those applications that require high mobility or application where long communication range is needed. Let's take a complete simple example. We can think about an outdoor IP camera where the Wi-Fi 6 range may not be sufficient. So in all this case, 5G will be useful. And just another point to see from my understanding, organization will prefer to use Wi-Fi 6 for indoor or on campus or fixed network situation, while they will turn to 5G for outdoor or off campus on the mobile network systems. Okay.
Great, thanks. Next question I have, what are the main market drivers for Wi-Fi 6 adoption in industrial applications?
Oh, this is a very interesting question, and this topic is really close with Telit DNA because for industrial Wi-Fi modules. I think there are several reasons for adoption of Wi-Fi 6 in industrial. I'll try to illustrate briefly. So first of all, Wi-Fi 6 can help to improve the quality of the final product. Explaining it easily, having access to more information about the process can improve the operation and the final quality of the product. Let's say, take an example. For example, the steel industry could adopt cameras to monitor the thickness of the product that is leaving the rolling machine. So with this all additional information that is provided by Wi-Fi 6 streaming capability, there could be adjustment real time in order to ensure the proper control of the final product. Another driver could be an improvement of the yield thanks to Wi-Fi 6. Again, as we have seen, with more information coming from sensors and monitor, industry can employ new analytics to improve the yields. Let's say, for example, manual inspection can be replaced with artificial intelligence visual system that will reduce the error and finally improve the yield. So, in other words, we can say that problems could be identified earlier in the process and reducing the cost of repairing it later. Another driver is for sure safety of the industrial process. Let's think about industrial process that include blades, high temperature, high pressure, robotics. So these are a big concern for the safety of the engineering or the people that are moving the facility. Normally, all these safety systems are wired, but if we could add a wireless system, this system could enhance monitoring the monitoring of the could enhance the safety and the monitoring of the process for safety. So for sure, Wi-Fi 6, as we've seen, support a lot more of wireless devices. Next driver that I think is just a position under quality yield safety is security. Simple example, if we think about physical security plant, we think about entry controls and so camera, keypads, locks, every control to ensure that only those with the proper authority have access to the facility. So again, having the possibility to add more of these devices in the same location will increase the physical security of the plant. And again, talking about security, we cannot forget cipher security and the implementation of the WPA3 standard that Wi-Fi 6 support. And let's say another final, there will be lots of more drivers, but another one that I think is important is that Wi-Fi 6 could reduce the downtime of the production line. So if a manufacturer could employing sensor or different way of monitoring the production line, problem could be identified as soon as they come or could be anticipated. This means that the production line will be in downtime for shorter period of time, and for sure the final result will be better, more productivity for the fab. Okay, so these I think are the main drivers for Wi-Fi 6 adoption in the industry.
Great, thank you. This next question kind of goes hand in hand with the last one. Can you comment on Wi-Fi 6 adoption trends?
Yes, sure. So the standard has been finalized a few years ago, but now there are several research that show that Wi-Fi 6 adoption is growing more and more. I think that I can mention one particular research from IDC that estimate that Wi-Fi 6 will account for almost 80% of all Wi-Fi production in the next 2 years. So I mentioned before, we expect to see more than 4 billion Wi-Fi 6 product shipment in 2022. Another report that came to my mind is from the Wireless Broadband Alliance that states that I think around 83% of service provider and equipment manufacturer will be adopting Wi-Fi 6 or Wi-Fi 6E before the end of 2022. So 83% of all service provider will be implementing Wi-Fi 6 before the end of this year. Okay. So let's say that the Wi-Fi 6 is growing and is not going to stop soon. Is there any more questions?
Yeah, I think we've got time for maybe one more, if you're okay with that. This next question I have, all these Wi-Fi 6 new technical improvements are really future-looking, but what about backward compatibility, maybe with like older iteration of the standard?
Oh, okay. Yeah, this is again a good point that I touched briefly in my second slide, and this is a good point. So indeed, Wi-Fi 6 has been designed from the ground up to be, for sure, forward-looking, but at the same time, maximum backward compatible with older devices and legacy standards. If we take a legacy client, for sure it will not be able to use all the new features of the Wi-Fi 6 standard. However, there will be there will be more time for this device in the network because if we consider Wi-Fi 6 client connected in the same network, this could take advantage of the new feature. So all the legacy product, all the legacy client, let's say, could benefit from the adoption of the Wi-Fi 6 network and Wi-Fi 6 client. So therefore, the overall efficiency of the system will be improved. Something also for sure that I would like to mention is that if you deploy Wi-Fi 6 access point, for sure it cannot improve the performance or range of any legacy Wi-Fi client. But again, the overall performance of the network will improve. Okay. This is, I think, hope this answers the question.
Correct. I believe that's all the time we've got for today. We're kind of coming up on the hour here. Please be sure, audience, to check your inboxes in the coming days for that replay link that we'll send out. Carmelo, thank you so much for your time today, and thank you all who joined us.
Thank you, everyone.